We're up? All right.
Okay, this is pen testing over Powerlines. Again, last chance to walk out if you were here for something else. So about us, my name is Rob Simon. I'm an application security engineer at a Fortune 100 company.
1,000.
1,000? My bad.
Yeah, dude, don't give us more.
Giving us too much credit. Penetration tester, I do source code analysis, reverse engineering, code obfuscation, and I've been known to do a little bit of video game hacking as well.
All right, hi, I'm Josh Kelly. I'm a security engineer at a Fortune 1000 company in Northeast Ohio, right by the Akron-Canton Airport, and I work for Dave Kennedy back there. So, in case you didn't know, he worked at Diebold. So, I've spoken at DEF CON, Black Hat, B-Sides. I speak about Tennessee devices a lot. I've also spoken about PowerShell, and I've given other security training and stuff like that. I'm a pen tester at Diebold. And I like to hit people with sticks. So if anyone's interested in getting hit with a stick, I'll do it. I'll punch it too, man.
I prefer Dave Kennedy's hugs.
Yeah, Dave likes to do hugs. I like to hit people, so I like to hit Dave too. So the big thing is that we're going to be covering 3 main categories. Initially, this is going to be about the power lines, communication over power lines, so what's called BPL. Then we're going to talk about home automation, which Rob here has an awesome demo lined up for you. Hopefully you guys brought earplugs for it. And then we're going to talk about some new some tools that we released for it, or actually Rob released for it. I'm not going to take any credit for that. And stuff like that. So, do you have anything to add about that, Rob?
No, I think that sums it up. So we'll go ahead and move into the broadband over power lines. So to give you a little background on what that is, it's a technology for, obviously broadband over power lines. It's taking an existing infrastructure that's already there and then using it to leverage, instead of building a newer infrastructure around.
Basically, what we don't want to do is people don't want to have to build new infrastructure. They don't want to have to run new lines, new fiber, all that stuff. So in a lot of places where we see this at is we see it over in Europe, where their infrastructure is already to capacity and they don't want to add any more to it. A lot of times you'll see this in residential areas, but you also are seeing it in corporate networks too, just simply because some of the devices that they're adding into the corporate networks are communicating over the power lines because it's a lot simpler. The other thing too about this is that this is what the smart grid is going to be using. It's going to be using the power lines for communication. So that way the utility companies don't need to add a lot of new infrastructure costs into what they're doing.
Yeah, Josh sums that up a lot better than I did.
So understanding BPL, obviously we're taking a medium that was meant for AC power and we're trying to put data across it. So one of the things that's the problem with that is that we get a lot of interference on things, so we need to make sure that our frequencies are right and all that stuff. So with higher frequencies, we can get higher speeds, but lower distance. So if we go with lower frequencies,
sorry.
Yeah.
If we stay a little farther away from it.
Dude, I'm subscribed to that thing, so I'm gonna hit it. I need to get closer?
No, the closer they get, the worse the feedback gets.
No, I'll turn the camera.
Hello?
And then we'll fix the
Is this better?
Yes.
My bad. Thank you.
Dude, so I'm used to having like a mic here. I'm not used to talking into these things. I hate these things. I'd rather have a mic right here so I can walk around. So, but yeah, so if you're using high-speed transmissions over power line, then you need shorter distances. So transformers and stuff like that are really going to mess with broadband over power line or BPL. But if you've got where you're doing slower transmissions, a couple kilobits a second or something like that, then you can do it over a long range. And that's what the utility companies are going to be doing. Another thing is that a lot of this technology came out same time like access points came out and stuff like that. So we're used to having WEP on the access point, so a lot of these things have 56-bit DES keys on there to try to secure them. So one of the things that's interesting about the technology is that it essentially turns your network or your home power lines into a hub, just a giant hub for you. So it's really easy to gather the information, sniff it, do whatever you want there. So that's why they introduced some of the keys. Newer stuff that you go and buy in Best Buy now will have like AES, but I mean, that's few and far between. Most of the stuff you're going to find out there, it's going to be DES.
And yeah, to speak on that a little bit, one of the devices that we've seen out there, some of them use the 56 DES keys, like Josh was talking about. But we have seen some actually, like he says, with AES, and they actually have some of them where you can find where you plug one in, you plug the other in, to bridge the Ethernet over there. And then to set up the keys, they actually have a push button on them, so you push it and it does a randomized key at least, rather than using like a static key or a key default key that's embedded in it. So there are some good ones out there. I think that was a Netgear. I think we have the model on there somewhere. But
yeah, we grabbed a Netgear. We went to Best Buy, bought that one day, so we got to play with that. But it's not so much about breaking into those networks that we're interested in. It's how we can leverage those networks in a pen test. So again, smart grids. Everyone's worried about Big Brother watching your TV consumption, your refrigerator consumption usage, all that stuff, giving you a report every month. Well, that's how they're going to do it. They're doing it through this standard. It's IEEE 1901. I think the RFC was released 2010. It was published in just February of 2011. So we kind of went over this a little bit, but here's one of the Netgears that we found, or the D-Link actually, but what we bought was a Netgear. So the default keys on these things though are pretty simple, pretty easy to break into. A lot of them are like linksys or whatever, admin, stuff like that. It's not, but again, this isn't the big thing that we're focused on. We're focused more on what can we use in a pen test for people never to find. So here's where we talk about a real world scenario.
So Josh and I actually did a pen test on a physical pen test on a company not too long ago, which was kind of interesting. And we had an opportunity to make use of one of these devices, which was kind of interesting. So what we did is we used some social engineering to get into a building.
Yeah, so real quick. So we were told that social engineering was included on this pen test engagement. And they wanted to do it cloak and dagger style. They didn't tell us anything. We had to find everything out on our own. They were like really big into this stuff. They were like, yeah, we want cloak and dagger. Find out everything you can. Tell us, and then we won't tell you anything until we're done. So we're like, okay. So we called up. We found out where their corporate headquarters was, and it was in an office park, and they were like the top floor of this building. So we called up the landlord. We were like, okay, what's going on? We're in from this consulting company from the Midwest. We're moving out to the big city. We like your office park because it's right next to big customer A and B. So what's going on? And they tell us a little bit about it. They tell us that there's some open spaces in their office, and we're like, oh, cool. Can we walk in and see? And they're like, yeah, go ahead, walk in. Those unused offices, they're all open. You can go walk through and take a look at everything. So we walk into there, and we identify where our target is, and the target's on the top floor. So we're like, okay, well, let's check out the floor below that. So we go to the floor below that, and we take a look at the wiring closet there. And most cases, everyone's got their own separate networks, their own separate wiring closets, so we couldn't figure a way to bridge into their network from the other office. But we did take a look at the power lines because we were developing this talk and we had already done this once at DEF CON. So we were like, okay, let's look at the power lines. What can we use here? We were able to identify that the power lines were shared amongst the entire building. So we're like, okay, great, this is awesome. So that means if we can get somewhere up in there, we can plug in one of our BPL devices, connect it into their network, and then stay downstairs and hack away with no one ever to be able to detect we're there. So we sent one of our guys in.
Yeah, so what we did is we actually sat around the company in the parking lot, sitting there around 12:30, waiting for people to come in and out of lunch. One of our guys went in before us. We waited a couple minutes after that. We went in a few minutes behind him, carrying laptops and bags and stuff like that. We just went in having a conversation with each other, trying to make sure no one's going to stop us, bother us. We go up straight to the third floor because we know straight where we're going. We walked straight ahead to the right. Seen someone coming out the door at the same time, so we reached over and grabbed the door from her as she's opening it, just said thanks, keep walking. So we got past the RFID scan doors, we were able to get right in, and we see another door, and we're in like a break room area. So we go ahead and sit down for a minute, because we don't know if those doors have access control or anything on them. So we sit down for a little bit, mess around on our laptop, grab a snack from the vending machine, have a conversation, and then we're keeping an eye on the door, and we notice that people are coming in and out of it, no one's scanning, so we realize we're able to just walk right through that door at that point. We've already got past all the access control they had. So we went ahead, packed up our stuff, got up, walked through that door, and we just started walking, looking for a place to sit down. We ended up coming across the conference room. So we go in the conference room, we sit down, and they happen to have a small conference room with one table and a VoIP phone sitting on the desk. So we were able to see that there's a plug behind the desk conveniently where you can't see what's plugged into it. So we were able to actually plug one of these devices in, run a cable from the VoIP phone back to one of these things, and then get that set up in the conference room. And then before anyone noticed, because this is a small company, we didn't want to stick around in the area too much and have anyone questioning, who we are or what we were doing. We got up and walked out of the conference room, went back down a floor, and then we found some empty office space somewhere else on the second floor that we could plug the second device in. And we were able to actually bridge the Ethernet connection from the company that we're doing the pen test to down another floor to a separate company that had empty office space, and we could sit in there and do our pen test undetected.
Yeah, so we were down there for 4 or 5 hours. We'd port scanned the network, ran our vulnerability scans. The customer didn't want us to actually break into anything, so we couldn't actually try to compromise the network, but we were able to do enough that we were able to show that, hey, look, we were able to do this. You guys had no idea that we were there. So we decided that it was about time to go let the CSO know that, hey, we're on site and we've broken into your network. And as we start to go in and we've tailgated into another area, we see our coworker that we had left in there the whole time. He was trying to figure out, what he can break into and stuff like that. We see him being escorted by some of the security guys, and we're like, oh shit, we're screwed. So as he's being escorted out, we're like, oh, well, we went and grabbed our device real fast and started walking out. When one of the guys that was escorting him out comes over and it's like, hey, what are you guys doing? And he's like, hey, can we help you out?
He says to me, can we help you? And I said, no.
Yeah, we don't want your help. We're good.
So, yeah,
he's like,
I'm good. I'm just on my way out.
So we told them we were consultants, and they're like, oh, who are you working for? And we're like, we're looking for that guy. We just point some random guy.
And this is the same guy that we watched escort our other guy out too. So we already know he's caught us, and we can't really talk our way out of this one. So.
Yeah, so we eventually gave it up. But what we did do was we recorded a video while we were doing this. So I'm going to play this video for you guys, because this video is, you guys will laugh at this. This is hysterical. What? This is not. Are you serious? Dude, we grabbed the wrong video. What? No way. I gotta play that one again.
So we lied. There's no video.
Oh, there's video.
But there's a video of Dave.
I hate this. So yeah, just so you know, this is the founder, one of the founders of DerbyCon. This is what we do in the office, and people say we don't work.
Dave's not actually in here right now, but if you happen to see him around the conference, just go up to him and tell him he's a pretty good dancer.
Yeah, if you're interested in more pictures of Dave Kennedy, come to my talk tomorrow, and there will be more. Awesome.
Extremely relevant.
Very relevant, and it's very important to know because Dave threw us on this talk at the last minute. So this is what he gets.
That video is going to the large projector later. We need a copy, just FYI.
Will do. So we really do have video. Unfortunately, we can't show it because it's got customer information and stuff like that in it. So, but needless to say, it was pretty cool. But another thing that we were able to, what? Hugs.
The problem is the guy that said that, he saves everything, so he's got like 400 other things that I've done that he's
Hey Dave, just come to my talk tomorrow. So we figured you guys would like that. Oh, we get some mood lighting.
It's setting the ambience.
Too bad Relic left. I mean, I want to get a hug now.
Okay,
Another thing that we can do with, sorry to cut you off there.
Go ahead.
But another thing that we can do too is that a lot of companies will sometimes have power lines exposed on the outside. They'll have their outlets out there. So we can go inside the company, plug in one of these BPL devices, connect it into the network, and then be able to hack from the outside. So one of the things that we were thinking about when we were on this engagement was, wouldn't it be great if we had like a Pony Express? Because we have one back in the office, and we got the 3G card with it. So wouldn't it have been great if we could have just, used the Pony Express, plugged it into the BPL, BPL was plugged into their network, and then we could have just been wherever we wanted to. We could have went back to the office, we could have went back to the hotel, poolside, sitting there watching the babes in the water, hacking away at this company's network, and they'd never even know we were there for how many days or weeks, who knows. So that's another example of what we could do. Unfortunately, we didn't bring the Pony Express with us at the time, so we weren't able to actually get that one fully realized. But I mean, these BPL devices are just awesome to be able to bridge networks wherever you want and just create an ad hoc network that doesn't stand out. It doesn't stand out at all. You can have this in a data center, plugged into the back of a rack, plugged into the network, and then you could be in the bathroom, on the toilet, doing something if you got power outlets in the bathroom.
And the Pony Expresses are great, but they're pricey. So if you're on a budget, these things they don't cost that much. I think around $70 is what we paid for ours. So
yeah,
it's a lower cost alternative.
Yeah, one of the things that we wanted to try to do that I started work on is taking apart. Everyone's familiar with those little UPS batteries that just look like a giant power strip. Well, I saw the Pony Express guys, they had a Pony Express inside of it. So I was like, oh, that's great. What happens if I include a BPL in that? So now I just plug in just this power supply and that's it. That's all I gotta worry about. I don't gotta worry about wires, plugging them around, doing anything like that. Have my 3G card inside of there. And great, now I have this awesome device I can start hacking the network with. That's what I was thinking. So I started work on it. It's not done, I couldn't bring it here, sorry.
So some of the other stuff that we're looking over the power lines is the home automation stuff. A lot of you are probably familiar with some of these things. You've got the X10 protocols, you've got Creston, Lutron, Zigbee.
Who doesn't remember their X10 pop-ups popping up like 5-10 years
ago?
ago?
So X10 was around for a while. It's been around a while ago. It's cheap stuff. And basically, you got a couple different devices that you can buy with that. You got appliance plugs that you can plug in to control your appliances. You've got plugs that you can plug in to control other things like that. So we got some of the devices here. We've got like a remote that you can control your lights with. We've got
Here's an appliance plug.
Plugs. So they're really cheap. They're like $7 a piece.
Transceiver plugs.
We thought that these were an interesting thing to look at because the protocol is actually pretty well documented. It's out there. It's been around for a while. The devices are cheap to get a hold of. So,
Our custom plug?
We'll talk about that one in a second. So what we thought was interesting about this is some of these home automation things, specifically the X10, was actually used. It's still used in home security systems, and we were actually curious how secure are one of these home security systems running off of X10. So we did some tests, and we've got some demos that we're going to show here in a second. So first we'll go over the basics of X10. Like I said, it's a highly used with the home automation community. I think it's one of the more popular ones that are out there. And like we said, some of the equipment that you can hook up to it with the appliance modules, I don't remember what they can handle up to.
256.
But they can handle some pretty big devices, so you can plug your heating or cooling into those things and control those with a remote, turn them on and off. You got your lights, the security systems, they got cameras that are controlled by X10. Door sensors, window sensors, motion sensors. So there's all sorts of stuff out there that speaks the X10 protocol.
Yeah, we've got some guys that work with us that have taken X10 and really just the home automated their home. You know, they walk into a room, they've got a motion sensor that sends an X10 signal to the control center. The control center then turns on the lights to the appropriate level that he wants it. The windows open up, the TV turns on. It's all sorts of stuff. We stayed at we got to stay in the Aria for a day or two. When we were out at DEF CON. Hello?
Keep the mics apart and stay and talk into the mics.
I'm not a sound guy. I don't know this stuff. Is that better? All right. Sorry, guys. We're not sound guys. We're computer geeks. I mean, we sit there and play on computers, not fiddle with little pots and stuff. So we stay at the Aria, and there's all sorts of stuff, all sorts of this X10 stuff going on there. We actually played around with it. It wasn't X10. It was a similar protocol.
It was Control 4 or something like that.
Forward a little bit. So obviously there's some drawbacks with X10. Mainly, there's no encryption on it. This protocol was created in the 70s. There's no encryption around it or anything like that. There's really no security around it. There's only allowed 256 devices that can communicate on this network.
Still getting slight feedback, I think. This way? I'm trying to figure out where to stand. I'm sorry.
Yeah.
Best I can do is like
it's
shake
working.
it around and hope it goes away. Thank you.
All right. The other thing about X10 is, again, like with Powerlines or with the BPL stuff, it's subjected to interference a lot. When you're actually sending a signal over X10, it doesn't just send the signal once and hope that it got there. It sends the signal like 4 times, and you'll watch it when we do this stuff. You'll notice that there's a delay of a few, not seconds, but a noticeable delay in milliseconds.
Yeah, we actually won't see that big of a delay on our demo, but when you plug it in your home, you've got a longer distance with the power line. So the longer it goes, the more of a delay you're going to get, and the more chances of interference you're going to have to pick up. So, like Josh said, they lack encryption. Only 256 devices. There's actually a RF that they can talk over to. Some of the devices speak over RF. They have an RF transceiver to try to get a little bit more distance out of them. And we actually looked at that a little bit too. They run on 310 megahertz in the US and 418 megahertz in Britain and Europe. And we actually found they don't do frequency hopping or anything like that. So an interesting thing is you're able to actually do RF jamming on those. So we can send out a signal to prevent them from talking. And what's interesting about that is the windows and door sensors and the motion sensors, they actually speak over the RF. So if you're going to be tripping one of the RF things to set off one of the alarms, you can actually run an RF jammer since they're not doing any kind of frequency hopping, and that just prevents all the signals from traveling over the RF. So that kind of kills the motion sensors.
Yeah, well, there's some security documentation and protocols around this. None of it's official, and none of it's really out there. So while we were looking, we found like references here and there, but we couldn't find any like single source of the information.
And just to clarify, there's kind of 2 parts of the protocol. There's the X10 protocol itself, and that's the one. It is well documented, but then there's the extended codes, and then how the communication over RF happens. And that's the one that's kind of unofficially documented. It's a little bit on the internet, and there might be some missing details out there.
So to give you guys kind of an idea of how simple the X10 protocol is, these are essentially all the codes that you have. It's just 4 bits. There's some bits in front of it to tell you which device this is going to, but that's all you can really do. The extended codes, obviously they add some extra detail in there, but there's not much more that it fleshes out. So here we have the X10 kit. What we have here is we have the transceiver on the left, which connects in with just a phone line, so it can plug into something like an Arduino, which is what we use to do this stuff with, or it can plug into whatever command center that you have. And then we also have the plug on the other end. This is what you plug your device into. So your light would plug into this, your whatever would plug into this, and there's dials on it to give you an idea of which device this is. So you got A, B, C, D, E, F, G, all the way through Z, and then you can say device 1 through 4 or 5. So this is what Rob was working on.
So seeing how simple the X10 protocol was, and being that they had security systems that are running over this protocol, we thought, how easy is it to sniff the traffic, and what kind of things can we see going over there? So we had a prototype device that we started building using an Arduino, And what the purpose of this is to plug that in and hook it into the power line somehow and try to catch those communications that are going back and forth and see if we can't monitor the codes. Interesting thing that you could use this for is say an area or a building or whatever, a home, they're using X10, they're controlling their lights. Maybe you could plug in a device that would monitor the transmissions going back and forth so we can see when the signals are sent for the lights to go on or the lights to go off. And we can kind of get an idea of when are people in their house, get a profile on them and determine maybe when's the best time when's the best time to break into either a company that's using this or a home that's using this. So, and the cool thing about it is, since it's going over the power lines, you don't even have to have access into their home. If you can get a plug that's on the outside of their house, you could just plug your device in, and then you could sniff from there, and then come pick it up later and collect the logs off of it. So we've got the Arduino here with us today, and I can show you a demo real quick of the sniffing. So we've got this is the transceiver that you get when you buy the X10 stuff. It uses just an RJ11 jack. So we wired this up to the Arduino to listen to the protocol, and what this will do for you is this actually sends the signals over the power line for you, and then it will decode the signals, and then it sends the stuff over the RJ11 jack. So then we hook that into the Arduino will interpret what that is, and then it's going to print it out to the screen for us.
Go back a slide? Yeah. Yeah, so that's right there, that's the configuration that we have here. So that's we just plugged the Arduino into a breadboard so that way we could map the pins correctly for the RJ11 cord.
Got to plug it in.
Can't monitor nothing. It's in your hand.
Looking for the USB cable. It's in my hand. All right, sorry about that. Don't have really too much space up here to get this stuff set up, so what we're going to do now is we got the Arduino that's running on here, and then we've got the remote. So this will send different codes to different devices that you have. You've got devices 1 through 5 on here, and then a couple other commands to brighten lights or dim lights and stuff like that. So what I'll do is I'll send some of the commands, and then you'll actually be able to see them as they're traveling across the power line. So this is going through our plug here, and then it's being picked up by this. And then if you can see it, the light on here is going to blink a little bit. I'll show you that we got an X10 command. And then it sends it into the Arduino, and then we're just printing out the commands to the screen. So because there's no encryption or anything on the protocol, or around the protocol, you can actually see whenever we send the commands. So we've got on and off, all lights on, all lights off. So that's the sniffer.
So the other thing too about the X10 stuff, and the same thing that applied with the BPL stuff, is that this turns your network into essentially, or your home power lines into a giant hub. The transformers will generally filter off this traffic, so you're not going to be able to see, the entire neighborhood's worth of X10 signals that are going on, but you can possibly see your neighbors' houses, your neighbors' houses, or whoever's connected all in with the same transformer. So it all depends on how the utility companies have set up your infrastructure there. So the more remote of a location you live in, the more likely you're going to see more people.
And like we said, they supported up to 256 devices. So the way that works is they actually have dials on the front of the device, so you can pick which house code are you going to be on and which unit are you going to be on. And whatever you set this to, this is set to A1 right now. So it's only going to respond to commands that are sent to house code A and unit code 1. So when we send this, this device, since they don't have any encryption, you can actually still see all the communications, so they don't pair with each other. Anything that you send is going to travel across all of your power lines, so anything that speaks X10 that's plugged in is going to see these communications. If it's not destined for whatever device, then it's just going to ignore the command. So that's how we're able to do the sniffing. We can still see the commands that are going through. It doesn't matter what device we are, we're still going to read that out and we're still going to print it out to the screen. So we thought that this was kind of fun, and we wanted to take it a little bit further than this. So this is kind of a mess up here with the Arduino, but we thought maybe we could build a smaller device, something a little bit more embedded, and then maybe we could do a little bit more with the protocol. So we decided to try to embed a Tinsy into one of the devices here, and this is going to be the fun demo here coming up.
Is everyone familiar with what a Tinsy is? Okay, good.
Okay, so the Tinsy is
we've hammered it before.
Just a small microprocessor, like the Arduino. It's just a lot smaller. It's easier to fit in small places here. So I am not an electrician at all, and I have 0 electrical skills. So here is a picture of us trying to figure out what we're doing and trying to source 5 volts of power to power this Tinsy. Because when we're powering this off of, when we're powering the plug here, we just got the RJ11 jack, and that goes to the Arduino. So we still have to power the Arduino off of power. So I mean, that's a huge mess. We don't want to have to lug all that stuff around and plug that in. That's pretty obvious.
Yeah, we want it to be nice, self-contained.
Yeah, so we tried to make it self-contained.
And this is what happened.
And it was really fun. So we got to learn about too much current, and we actually blew a Tinsy up, put some
Unfortunately,
holes in
what
it.
you can't see there is that there's 2 giant holes in the processor. One giant hole where you can see the bottom of the board, and the other one you can't quite see the bottom of the board.
It was working temporarily, and then it just blew up.
We had smoke, we had fire, the cops were called, it was horrible, it was a mess. So we decided that we'd find an electrical engineer that could actually do this stuff for us.
Yeah, so we did get a little bit of advice on how to properly step down 120 volts to a stable 5 volts and a low current. And lo and behold, we've got an actual working jammer device that we built. So.
Yeah, we didn't know what this thing was. We thought it was just some nifty thing, and then the guy explained it to us, and we're like, oh, Jesus.
So it just looks sweet. That's all that matters. It's a blue thing. It's electronics. It's gadgets. They're exposed. So what we're actually going to do now is I've actually got one of the alarms that go with the X10 alarm system. So what we're going to do is we're going to simulate an alarm being tripped, and then we're going to show how when we plug in the jammer, we can actually jam the communications for the X10 protocol and start sending a command. It actually shuts all the lights off in the house. So what happens when the security system picks up a signal, you trip a motion sensor, it's going to send an X10 command. It's going to go over the power lines or it's going to go over RF, and the security console is going to pick this up. What the security console is going to do is it's going to take that alarm signal, it's going to flash the lights on and off in the house, it's going to trip all the sirens, and then it's going to send a call out to either the police or a number that you've set up. So what we thought we would be able to do would be to jam those signals, kill all of your lights, prevent the calls from being able to go out, and completely disable your home security system. So
you guys might have seen something like this with Dave earlier if you were at Dave's talk with Kevin Mitnick, where he did this with Christmas lights. Well, Christmas lights are okay. That's been done before. So that's why we went with the alarm.
So we thought we'd go ahead and bring in one of the alarms and see if we could get this going for you guys.
So if you guys are, some people might want to close their ears.
All right, so we're going to trip off the alarm real quick, and then we're going to go ahead and plug in the device after the alarm's tripped, and then we're going to show that the alarm's not going to go off anymore.
It has a warning, extremely loud. I'll just unplug it. Unplug your mic before you do that. Again, I'm not a sound guy. And I'm stepping on wires.
Yeah, so what's going on right now is the jammer is actually sending a signal right now to turn all the lights off in the house, and then it's sending so much stuff through the lines that the communications is not able to happen between the remote and the alarm. So what you'll see here in a second is as soon as we unplug the device, the alarm's going to kick back on.
Unplug the mic.
We can make it loud.
We'll just turn it off.
So basically what happens there is if you're using the X10 for your home security system, we're able to monitor any of the commands that you're sending across. We're able to see anytime your alarm is tripped. We're able to see when your motion sensors are tripped. We're able to watch whenever a motion sensor is tripped, that means you're walking through an area. So even if your security system is not armed, your motion sensor is still picking that up and sending the signal to the security console. So even if your security system isn't enabled, but you're tripping your motion sensors, we can kind of track your movement around the house by sniffing the communications. We can see when your lights are on and off. We can profile when you're home. And then if we decide we're going to break in, we can even kill the whole system altogether, shut off your lights, and kill the alarms.
So, Relic, this isn't set 2.0 at least, right? Relic? What? This isn't set, right? Yes. Okay, so we left that, we put that in there because we were pretty sure he put it in there. So this is in set 2.0, at least that one or higher. So you have the sniffer in there.
So basically all you need is an Arduino or a Tinsy device, and then we've got the code is in there for set 2.0, so you can deploy Arduino payload to your Arduino or your Tinsy.
And then we also have the blackout, which is this device here. We have the code in there for that. So there's another communication protocol called Z-Wave that's also available. So we didn't really get to take a look at this too much. Unfortunately, the guy that did just walked out of the door. So he knew more about this than we did.
Yeah, so Dave and I gave this presentation at DEF CON this year as well. And Dave did a little bit more work on the Z-Wave, but what we did is we did some research on it. It's different than the X10. It uses mesh networks. So each device that's in the network acts as a node. So if you have multiple devices and you've got a range that you can't reach, but you've got another device that's in the path, it can hop from that device to the next device, so you get a better range. We would like to take a better look at this protocol, but unfortunately some of the hardware that was required to take a look at this was a little bit costly for us. The dev kit I think costs around $2,000, so if you want to donate, throw us some money. A lot of devices don't actually have support for encryption, but we did note one that was a door alarm on the next slide here. This is the one device that we did find. I don't think there still is any other devices yet that have them. It has AES encryption on it. But the thing that we did find is it appears that it's not using a correct FIPS compliant based transmission of the AES key. So if you happen to be sniffing, when that key establishment happens, you could still pick up the key in the process. So, and that was the only device that actually supported the encryption.
So, big thing. Any questions? Because we found out someone on our team really gets discouraged by brushing teeth.
Adam right there in the back. Staff shirt, walking out in the blue shirt. Where are you going? Okay, so yeah, the guy we work with, Adam, he's got a weird phobia of brushing your teeth. He actually left the room. If he sees it, it's like the frothiness or whatever. I don't know what it is that does it, but I think it's the frothiness. Whenever he sees that, he vomits. It's awesome.
Yeah, we almost got him to vomit a few times. It's pretty cool. But seriously, any questions?
Thank you for having my girlfriend run over by him.
Sorry.
Could you use like an antenna or like a preload antenna to like extend the signal or reduce interference?
For X10 or the Z-Wave? So the X10 actually communicated over the power line, but there was a few devices that actually did over RF. Now when it comes to the transmission RF CAN antennas, I'm not too knowledgeable in that area.
But yeah,
I don't see why you couldn't. If it is on the right frequency and you built your own antenna, I don't see why you couldn't use that to extend it.
Yes, you in the back.
Have you done anything with Insteon or Zigbee?
No, we have
unfortunately,
not.
We didn't really get a look at that too much. X10 was the cheapest and the one that was most freely or commonly available to us. So that's the one that we really looked at. We want to look at those other ones, but we just haven't got the chance to.
Yes.
When they switch the frequency of the AC, do you think it's going to mess all the extent up? Or is that on the subject? What's that going to do?
So again, like the low level of how it actually communicates over the AC, I'm not an electrical engineer, but the
Maybe exploited too. Is that I understand they're going to change the frequency of AC. Get in there and do it on purpose.
So there's the zero
Yeah.
crossing of AC, and that's actually where the communications are being done at. So if there's still the zero crossing, even if they're changing frequencies, it's not going to really matter too much because this is on a separate frequency unless it's the same frequency that they change it to. I think the frequency is, what's the frequency?
120,
Yeah.
60.
No, it was 60. Yeah, 60
Yeah.
hertz is what the frequency is that's going over across now, but this is shooting out at like something higher.
Any other questions? In the back?
With the X10, when you put the jammer in, can you target or does it affect everything between the areas?
It affects everything in that area. It basically what it's doing is it's telling everything to turn off. That's what the jammer does.
It's sending the signal to turn off all the lights, and then it's sending very rapidly to the point to where no other communications can happen. And it only goes. It's only going to go a range that the other X10 devices are going to be able to hear anyways. So if it can't reach some of the other devices that are in that area can't reach those devices either. But like I said, there's some of the stuff that can block that from working would be interference on heavy appliances like TVs sometimes. And actually another interesting thing that we forgot to mention is sometimes these signals can leak out between houses too. So they do have devices that they sell that you can put on the circuit breaker, but you have to be have a certified electrician or know what you're doing to get those on there. But you can actually pick up a neighbor's signal sometimes, so they may stray out. I think they get stopped by the transformers, but that's another interesting thing. You can get interference from a neighbor's house if they happen to be using devices. Or plug in, if you can get the interference, if you're getting signals from your neighbor's house, you could actually plug in a device in your house then to mess with your neighbor's stuff. Yes, back here?
In the case of the VGL device that you got planted at the company X, did they ever accept that it was there or tell us that it was there?
So the question was, at the company that we did the pen test at, where we used Broadband over Powerline, did the company ever detect that it was there?
No.
So they did not detect that. What we did was we just went in long enough that we could get that device plugged in, went down another lower level to a level that was controlled by another company, found an empty office down there, and then plugged the other one in, and then did our pen test from there. What actually happened was our other guy was the one that got caught. He ended up wandering around after he was done with what he was doing, and we were kind of finishing up, and we were kind of looking for the guy that hired us to do the test. And that's when they found us wandering around. They found Ryan wandering around. So, yes, in the front.
Another question about interference. Could you maybe, use like other houses to amplify the signal, like balance the signal kind of thing?
So yeah, you could use other houses, but
Like a
I said-
repeater?
like I said earlier,
Like a repeater, pick up the signal and then retransfer?
The transformer,
Yeah.
because of what it does to the power as it goes through that, is going to basically wipe out the signal. So you can't really go past the transformer. So even though you can do repeating and then like let's say a subdevelopment that's all on one transformer, you can do it there. And you can repeat and you can boost the signal and stuff like that. But once you hit the transformer that they're all connected to, boom, you're done there. So, yeah, you're welcome.